For centuries, science operated like a mechanical clock. Then came a mind that overturned that rigid framework entirely. Prior to the 20th century, physics followed the laws laid down by Isaac Newton. Space and time were viewed as absolute, a predictable, fixed stage where the universe played out its mechanical cycles. Born in the German Empire in 1879, young Albert Einstein was raised in a society defined by industrial order. Yet, while his peers studied the visible world, he became preoccupied by the invisible forces of nature. This curiosity made him an outsider in the classroom. He found the strict, rote-learning methods of the German gymnasium stifling, and his refusal to respect the authority of his teachers often led to open conflict. At 16, Einstein renounced his German citizenship to avoid military service, effectively becoming a stateless dropout. He was an individual operating entirely outside the traditional academic systems that typically groomed the era's elite scientists. Even after completing his studies at the Zurich Polytechnic, Einstein struggled to enter the professional world. For 18 months, he applied for junior lecturing and research positions across Central Europe and was rejected by every university he contacted. To support his family, Einstein eventually took a job as a third-class assistant examiner at the Swiss Patent Office in Bern. His daily work involved evaluating patents for synchronization devices and electromagnetic tools. Stripping these complex inventions down to their core mechanical principles trained him to visualize physical problems with startling clarity. While the established scientific community debated in academic journals, Einstein conducted elaborate thought experiments during his quiet hours at the patent office, examining the very nature of light and time. This deep isolation was his greatest advantage. Because he sat outside the academic hierarchy, he was free to question the foundational assumptions of physics that tenured professors considered settled. In 1905, the 26-year-old clerk published 4 papers that would replace the Newtonian model of the universe. Biographers call this his miracle year. His first paper explained the photoelectric effect. Light travels as distinct particles, or photons. Next, special relativity proved time is relative, slowing depending on the observer's velocity. Finally, his equation E equals mc squared demonstrated that a tiny particle of matter contains a massive amount of rest energy. In a single year, an obscure patent examiner provided the theoretical foundation to understand the behavior of light, the movement of molecules, and mass-energy equivalence. Einstein spent the following decade refining his work, attempting to integrate gravity into his new worldview. In 1915, he completed general relativity, proposing that gravity is not an invisible pull, but the physical warping of space and time caused by mass. This was proven during the solar eclipse of 1919. Astronomer Arthur Eddington observed starlight physically bending as it passed the sun, providing the empirical evidence that Einstein's equations were correct. The discovery was a sensation. The press announced that the Newtonian model of the universe had been superseded, and Einstein became the most famous scientist on the planet. After winning the Nobel Prize in 1921, he embarked on global tours that drew massive crowds in South America and Japan. He became a fixture of the public sphere, often appearing alongside cultural figures like Charlie Chaplin. Einstein had reached a position of immense global influence. However, the political environment in his native Germany was turning dangerously hostile. In 1933, the rise of the Nazi Party brought an end to Einstein's life in Germany. Facing persecution due to his Jewish heritage, Einstein, a lifelong pacifist, was forced to renounce his homeland and relocate to Princeton University in the United States. In 1939, European scientists discovered nuclear fission. This discovery provided the mechanism to convert Einstein's mass-energy equation from a theoretical concept into a physical weapon. Concerned that Germany would build an atomic bomb first, Einstein signed a letter to President Franklin Roosevelt warning of the danger. This communication was the catalyst for the initiation of the Manhattan Project. Although he took no part in the project's research, Einstein was horrified by the destruction of Hiroshima and Nagasaki in 1945. He spent the rest of his life regretting the role his signatures and research played in their creation. The man who spent his life deciphering the elegant harmony of the cosmos had provided the theoretical framework for humanity's most destructive capability. Following the war, Einstein became an outspoken advocate for nuclear disarmament, publicly declaring that humanity must give up the practice of war to survive the atomic age. He turned his attention to humanitarianism, supporting civil rights, global government, and the Zionist movement, which sought to establish a sanctuary for the Jewish people in the Middle East. In his final years at Princeton, he pursued a unified field theory, a search for a single set of equations that could connect gravity, electromagnetism, and all the physical laws of the universe. He died in April 1955 at age 76. True to his humble nature, he refused life-prolonging surgery, choosing to meet his end with dignity. Einstein's legacy is visible in the technology we use every day. Global positioning systems and the nuclear power grids that energize our cities trace back to the thought experiments of his early career. Albert Einstein proved that observation and curiosity could challenge 2 centuries of established dogma, leaving an impact that reaches from our deepest technology to our understanding of the stars.